Okay, let's talk about finding the area of kites and other polygons, regardless of what type they are. So when I look at a kite and I think about finding the area, I do not think, oh, the area of a kite is 1/2 times diameter 1 times diameter 2. Unless I happen to be teaching this particular chapter. That's not something that I'm going to remember all the time, okay? And so when I look at a figure like this, I start thinking about how can I find the area. You know, I look at this and I just see some triangles, okay? So if I can find the area of a triangle, well, then I can find the area of this figure. So let's look at it that way. So I'm just going to divide this into two triangles, okay? And I suppose we can call this diameter 1, okay? And let's just concentrate on finding the area of this top triangle right here, okay? So in order to find that, we need to know this altitude right there. And I'm going to continue that on down a little bit. We'll look at it down in here as well. Because that entire length, that entire piece right there, we're going to call that diameter 2. And so I suppose the altitude up here would be half of diameter 2. Okay, hope you can read that okay. So I know the length of the base is diameter 1, and I know that the height is 1/2 of diameter 2. And so I guess the area of just the top part of our triangle, just this section up here, okay, would be half. Remember, area of a triangle is always half of the base. Now the base is diameter 1, sub 1, times the height, and the height is 1/2 of diameter 2. Okay, so the area of the part that I've got highlighted there in blue would be, well, let's see, 1/2 times 1/2 is 1/4 times diameter 1 times diameter 2. So there's the area of the top triangle up here, okay? And what do you think about the area of the bottom triangle? Okay, I think they're congruent triangles. So I suppose the area of the bottom triangle would also be 1/4 of diameter 1 times diameter 2. And so that makes the entire area of the kite, let's just add these two together, okay? 1/4 plus 1/4, that's 2/4, times diameter 1 times diameter 2. And I hope you know that that would be 1/2, wouldn't it? Okay, so that's how I look at it. Whenever I look at a polygon, I'm thinking about how can I find the area of this thing, just making a bunch of triangles and dividing it up. Okay, so now let's talk about how that affects or makes the outcome when we were talking about regular figures. Okay, using the apothem, which is, remember, is the distance from the center of the figure to one side. And you can draw that apothem to any of the sides. They should all be the same length. So that's our apothem right there. Okay, and then the sides. And so the formula here is 1/2 the apothem, which is this distance right here, times the perimeter of the figure. Okay, or I think the one that we actually use a little bit more often is this one, where it's 1/2 the apothem times the number of sides, which in this case would be 3, times the length of each side. So you can see that the perimeter would be the same as the number of sides times the length of each side. Okay, So I made you do this one. I believe the apothem was given as 4. Okay, and we can figure this out because we can actually figure out just from that what the length of a side is. Okay, and we know that we have 3 sides, so we already know the apothem is 4. Okay, we already know that the number of sides is 3, and all we need to figure out is the length of a side down here, and this is actually doable for you. Okay, because when we draw a radius in, let's think about what type of triangle that we get right here. Okay, so we know that each of these angles is 60 degrees. Okay, so that one right there is 60 degrees. And the radius is an angle bisector. So each of these angles, they're congruent. And if this whole thing is 60, then that makes that one 30. And we know this is 90. So this is 60 up here. We have a special right triangle, don't we? We have a 30, 60, 90 right triangle. And we know that the length of the short side is 4. And so, well, if we know that, then we know that the hypotenuse is 8, which isn't really helpful in this case. But the length of the long side would be the length of the short side times radical 3. So 4 radical 3. Okay? So, all right, how long is the entire length? Well, it's 2 4 radical 3's. So 4 radical 3 plus 4 radical 3, they're like terms, just like 4x plus 4x. So we have 8x, or 8 radical 3. And now we actually know the length of one side. Okay, we can find the area of this triangle. So we have, I don't know how you guys want to do this one. We can go half of 4 is 2. 2 times 3 is 6. 6 times 8, that's 48 radical 3. And that would be the area in square units right there. And remember, you can times it out however you want. If you want to go 4 times 3 is 24, and 24 times 4 is 96, and then half of 96 is 48, whatever's easiest for you. And then here again, we have an exact answer. We don't need to get out our calculator and ask the calculator, okay, what's 48 times the square root of 3? Unless you're specifically asked to give an answer to the nearest tenth, or to the nearest hundredth, something like that. This is if you're asked to give the exact answer, or the anyway, the exact answer. Let's give it like this. This is in terms of the radical, and that's good enough.